An anglerfish, a rarely seen deep-sea predator, recently appeared on the surface, leaving scientists both stunned and curious. These mysterious creatures typically inhabit depths between 2,000 and 3,300 feet, where total darkness dominates the environment. Anglerfish have evolved to survive in extreme conditions, including crushing pressures, scarce food, and freezing cold waters. Their grotesque appearance, with sharp teeth and bioluminescent lures, makes them perfect ambush predators in the abyss. For a creature so perfectly adapted to the deep, surfacing is both dangerous and biologically abnormal. Deep-sea species like anglerfish experience lethal physiological stress when exposed to sudden pressure and temperature changes. At such extreme depths, water pressure supports their bodies, organs, and delicate tissues, preventing collapse or injury. Rapid ascent to shallow waters disrupts this balance, causing internal damage through barotrauma and gas expansion. One common explanation for deep-sea fish surfacing is illness, injury, or disorientation caused by internal organ failure. Injured or diseased anglerfish may lose the ability to regulate buoyancy, causing them to drift upwards uncontrollably. Pressure-sensitive swim bladders, if damaged, can become overinflated at lower pressures, forcing fish to ascend. Once at the surface, deep-sea species like anglerfish are completely out of their evolutionary element. Bright light, unfamiliar predators, and higher microbial loads expose them to conditions they cannot tolerate. Surface waters are warm, oxygen-rich, and turbulent, the exact opposite of the calm deep-sea environment they evolved to inhabit. Despite this, some scientists suspect that environmental changes may be contributing to rising reports of deep-sea strandings. Climate change is altering ocean temperature gradients, shifting the boundaries between deep and midwater habitats. Rising ocean temperatures affect thermoclines, the thin layers separating surface water from the deep sea. These thermal disruptions may confuse deep-sea species like anglerfish, disorienting their vertical navigation. Deep-sea predators rely on stable environmental cues to regulate hunting behavior, reproduction, and migration. When temperature gradients shift, species accustomed to narrow environmental ranges may drift into unfamiliar shallows. Ocean acidification, another consequence of climate change, may also disrupt deep-sea food webs and chemical cues. If prey species migrate upwards to follow shifting nutrients, predators like anglerfish may follow them. Changes in prey availability could force deep-sea predators to move into food-scarce regions outside their comfort zones. Some researchers theorize that climate-driven oxygen depletion could shrink habitable zones for deep-sea species. Warming water holds less dissolved oxygen, reducing the already sparse oxygen levels in deep-sea environments. This expanding hypoxia could create habitat compression, forcing deep-sea creatures closer to the surface. Anglerfish, unable to find food or stable oxygen levels, might ascend in search of livable conditions. Another theory links deep-sea strandings to seismic activity disturbing benthic ecosystems and displacing marine life. Undersea earthquakes and tectonic shifts release pressure waves that could jolt animals from their resting zones. If an anglerfish experiences sensory overload from seismic disturbance, it could become disoriented and ascend. Increased deep-sea mining, which disrupts seafloor habitats, may also contribute to displacement of deep-sea species. Plumes of disturbed sediment can block visual and chemical cues anglerfish rely on for hunting and navigation. If an anglerfish loses its ability to detect prey or mates, it may drift into shallower waters by accident. These factors, combined with natural illnesses and injury, may create perfect conditions for surface strandings. The bioluminescent lure that anglerfish use to attract prey becomes ineffective in the bright surface environment. Surface predators, unfamiliar with anglerfish, may avoid or attack them, adding further stress to disoriented individuals. Anglerfish exposed to bright sunlight suffer retinal damage, losing the visual adaptations that serve them in darkness. Their fragile, gelatinous bodies, designed for deep-sea pressures, collapse easily in low-pressure environments. The soft, underdeveloped skeleton of many deep-sea fish offers little support once surface pressure takes hold. Sudden decompression can also rupture internal organs, causing catastrophic physiological failure before they even reach the surface. Despite these biological disadvantages, some anglerfish survive long enough to be discovered by beachgoers or fishermen. These rare events provide scientists with valuable opportunities to study a creature rarely observed in its natural habitat. Tissue samples, genetic analysis, and chemical testing help researchers understand how stress affects deep-sea species. Anglerfish brought to the surface can reveal clues about deep-sea food webs, environmental stressors, and climate impacts. The recent increase in deep-sea strandings raises questions about whether the deep ocean itself is becoming less stable. Rising carbon dioxide levels, declining oxygen, and disrupted currents could all influence deep-sea ecosystem health. If environmental instability spreads into the abyssal zones, species like anglerfish could face population-wide displacement. The deep sea was once thought of as a stable, isolated refuge, buffered from surface climate impacts. Scientists now understand that climate change reaches all depths, altering even the most remote ecosystems on Earth. Anglerfish strandings offer a rare and haunting glimpse into the hidden consequences of ocean warming and acidification. The more frequently these deep-sea creatures surface, the more urgent the need for deeper ecological investigations. Studying stranded anglerfish may help scientists reconstruct the shifting conditions in deep-sea habitats. Each surfacing event represents a biological signal, a warning that ancient ecosystems are under growing stress. Combining biological data with oceanographic models can help scientists map habitat shifts invisible to the human eye. Some researchers believe anglerfish strandings could act as sentinels, revealing stress points in global ocean systems. If anglerfish strandings increase, they may indicate the collapse of deep-sea food webs or growing oxygen crises. Understanding these events could help predict cascading changes affecting not only deep-sea life but entire oceanic systems. Anglerfish, though rare and strange, embody the vulnerability of all life at the ocean's hidden edges. Their terrifying appearance masks extreme biological specialization, designed for one of the harshest habitats on Earth. Their survival depends on stable pressures, low energy living, and delicate balances that modern oceans are disrupting. When they appear at the surface, they reveal both the wonders and fragility of life in the deep sea. Every anglerfish that drifts upward offers scientists a fleeting window into the dark, ancient world they represent. These strandings capture public attention, but they also highlight humanity's deepening influence over Earth's oceans. Whether through climate change, pollution, or industrial disturbance, human actions now reach into the planet's deepest trenches. Anglerfish, drawn into light they are not meant to see, become symbols of an ocean out of balance. If deep-sea creatures are losing their homes, it signals broader ecological disruptions that will ripple across all ocean life. Scientists stress the importance of preserving deep-sea ecosystems, protecting not just anglerfish but the entire web of life. As the deep sea changes, every surfacing anglerfish reminds us that no part of the planet is untouched. Whether caused by injury, shifting habitats, or climate-driven collapse, these events demand urgent scientific investigation. Understanding what brings anglerfish to the surface could reveal early warnings for entire ecosystems at risk. These ancient predators, survivors of eons in the deep, now drift into unfamiliar waters, a testament to a changing world. The appearance of a single anglerfish at the surface may seem minor, but it could signify profound oceanic change.